Now, it's not actually a problem with leave one out. It's just a symptom of a larger problem. And the larger problem is imbalance of the classes. When you do leave one out, you're guaranteeing that the balance of classes in the testing set is not like the balance of classes in the training set. But this can also happen with cross-validation. Even if you don't do leave one out, you're doing random splits, you could end up with different proportions of each class in the training set and in the testing set, and that will mess up all kinds of learning algorithms. So the solution to this is something called stratification. And the stratification is, it's basically making sure that the proportions of classes in the training set are representative of the proportion of classes in your testing set. So basically the priors carry over between the training and the testing set. That's what you're doing. So a simple way to do stratification is, instead of taking your data set and cutting it randomly by instance, you take a data set, you cut it into individual classes. So in the simplest case, you take the positives, take the negatives, you cut the positives into 5 folds, you cut the negatives into 5 folds, then you take the first positive fold, the first negative fold, join them together, that's your fold 1. Second positive, second negative, join them together, that's your fold 2, and repeat that as many times. So you do that, you end up with a data set split that is balanced across training and testing. And that is a simple way to guard against all sorts of unlucky splits. It is still random. So don't get me wrong, you're still splitting randomly, it is still unbiased. You are just guarding against unlucky splits in your cross-validation.